you have your few moments to finish up that question. I'm going to draw your next ones for today. Yes.
40 times 10 is 400.
Yes, but you shouldn't be saying 40 times 10.
No, I just want to know.
Okay. 40 times 10, 40 times 10.
Yeah.
Yes.
So some numbers.
Should we be finishing up with that question so we can mark it? Okay, looking at number 4, I need to prove that they are similar. I'm going to start with the top triangle PQR, and matching to PQR would be TSR. We have the following. Since we have parallel lines, we can use that. So angle P is equal to angle T. Alternate angles are equal, with PQ parallel to ST. You have other options. You can do the other alternate. So Q is equal to S. Then you can either do third angle of a triangle, or you can do vertically opposite. Either one is fine. However, you have to use 3 letters. So P, R, Q, T, R, S. So that would be vertically opposite equal, angles vertically. Sorry, I had a brain fart. Vertically opposite angles equal, or you could have said third angle in the triangle. Either one you would have gotten that mark. Therefore, triangle PQR is similar to triangle TSR, angle, angle, angle. Now for my next question, I'm going to need to know what those sides are, so I'm going to write it out. PQ, QR, and PR, TS, SR, and TR, and they are all equal to each other because triangle PQR is similar to triangle TSR. And now we can go and substitute in the values that I can see. PQ is 10, PST is 100, QR is 4, and we have SR, which is Y, PR is X, and RT 20. So it doesn't have to be in alphabetical order, but you can put in alphabetical order. So I have 10 over 100 equals to X over 20. Cross multiplying, I have 100, X equals to 200. Dividing both sides by 100, X equals, is it 20?
No,
Just 2, yeah. Okay, let's do my Y. 10 over 100, 4 over Y. So we have 400 or equals to 10Y. Dividing both sides by 10, Y is equal to 40. Any questions? Can we look at number 5? Have we finished number 5? Anyone still needing to do number 5? Can I take this off the board? Okay, number 5. Anyone still busy with number 5? Can we mark it immediately? Let's mark it. Okay, proving that they are similar. I'm going to start off with triangle FGV and match it FZE. So we have F, which is common. Both triangles, the big one and the small one, has that angle, and therefore it's the same. We can say FGV, I have to use 3 letters, there is no other option, is equal to FVG, no, FZE, sorry, and that is because of corresponding angles being equal. GV parallel to ZE. Then I can do the other one, or I can say third angle of a triangle. FBG equals to FEZ. Once again, corresponding or third angle of a triangle. Lastly, we can now state that they are similar. Because of angle, angle, angle. For my next question, I'm going to use my ratios. And I'm using it because I know that they are similar. Triangle FGV similar to triangle FZE. Substituting in what I know. I know that FG is 3. FZ is 3 plus Y, the full length of that line. GV is 7. ZE is 49, FV is 5, and FE, the full length would be 5 plus X. Any troubles, grade 9s? Fantastic. Now when I want to solve, I'm going to use 2 fractions. 3 plus Y equals to 7 over 49. It's going to be the one set. The other set is going to be 7 over 49. It's equal to 5 over 5%. plus x. Now I have bracketed on purpose because when I multiply, I need to multiply to both of those things. So cross multiplying, my 7 is multiplied with the entire bracket, and 49 times 3 is 100 and something. 147. Now you have a choice. Either you can try and take the 7 over, or you can multiply out. Most learners tend to multiply out. 21 plus 7y equals to 147. 7y equals to 147 minus 21 equals 126. And then I can divide both sides by 7 to get my final answer of 18. Once again, cross multiplying. 7 times the bracket is equal to 5 times 49. Multiplying out, 7 times 5 is 35 plus 7x, 245. 7x equals 245 minus 35 is 210. Dividing both sides by 7, x is equal to 30. Any questions? This one was slightly trickier, especially if you forgot to bracket that denominator in each case. No questions? I'll leave it on for a moment for those of you that didn't get it. And then we will start with our number 6. Okay. Number 6. Draw and do, please. Number 6. Anyone still busy at number 5? Okay, I'm taking number 5 off. Going, and it's gone. Number 6. 7 we'll do together since it's not part of the outline. Yes, Amy. I did not show it to you. X would be this one here. Why is Lambda missing that value? That's O1, O2, X on top, 1.2 is AO. We're ready to mark yet? Not yet, okay. Okay, you should be done by now. So starting with my top triangle, and they give me the name so I don't even have to think too much. In triangle ABO and triangle DCO, A would be equal to D, no 3 letters necessary, there's no confusion. Alt angles equal with AB parallel to CD. I can also go O1 equal to O2 because of vertically opposite angles being equal. And then I can go B is equal to C. You can either do third angle of a triangle, or once again alt angles equal. Okay, therefore triangle ABO is similar to triangle DCO, angle, angle, angle. Now we're going to do our finding our missing side. So first two, second two, first and last, first two, second two, first and last. Why can I say that? Well, I've already proven that they are similar. So now let's substitute what I have. AB is X, DC is 5, 6. BO is BO, and CO is 4, 8. AO is 1, 2, and OD is 4, 8. So I actually, not that I don't need BO, so obviously not going to calculate it because I wasn't asked for it. So just those two will be 4, 8x, because x times 4, 8, and 1, 2 times 5, 6 gives me 6, 7, 2. Dividing both sides with 4, 8. I get that x is equal to 1, 4. Any questions? Why does it look like some people went wrong? Okay, what kind of triangle is ABO? Can we just make an assumption, or is it geometry and I have to prove everything I say? I have to prove. So I'm going to have to find out what BO is in order to know all 3 sides of that triangle, and only then will I be able to say what kind of triangle it is. So at the end of the day, I did actually need to know what BO is. Sorry, I just want to get on the same page. So I'm going to go with BO over 4, 8 is equal to 1, 2 over 4, 8. 4, 8 BO is equal to 5, 7, 6. Dividing both sides by 4, 8. BO is equal to 1, 2. So since, I'm going back to my triangle, since I have 2 sides that are equal, but this one is not equal, what kind of triangle is it? It's an isosceles triangle. And if I had to give a reason, 2 equal sides. Okay, number 7 and 8 we will do together. They are challenge questions, and it is not something that you are being examined on in November. When I first did it with the other group, we did not know that. So I will still do it with you. And I also think that everything we've done is super easy, and we do need to challenge our brains. Okay, normally this would be a normal, easier grade 9 question, but because we spent a little time on it, it's not being asked in November. So first thing I want you to do is to draw number 7. Well, if you want to draw number 7. Okay? So yes, I've included some fractions. It's always good to practice our fractions. Do I get enough or get given enough information to prove this similarity using angle, angle, angle? Definitely not. But I do get given quite a bit of information about sides. So proving this similarity would be an example of proving using sides in proportion. So they give me the names, so that also tells me or helps me to know which sides are the proportionate ones. So I'll still start my proof in the usual way. They gave me the names, thankfully. I know that I'm going to have to find what AB divided by DE is. I'm going to have to find what BC divided by EC is. And I'm going to have to find what AC divided by DC is. I'll zoom out a little bit so you can see the whole picture. So AB, thankfully, I've got that information. DE, I don't have. I think you're supposed to have it. Just give me a second. Yes, you're supposed to have it. It's supposed to be 5. Okay. BC is this entire length, which I tell you is 20. EC is the 6 2/3. AC is this entire length, and they tell me what it is of 35. And DC is a missing length, but we are able to calculate it because AD plus DC is equal to 35. I already know what AD is. So I use that to find DC. How would I do that? If AD plus DC is 35, how do I find DC? Matthew? I'm minusing. What am I minusing?
22.5 from 35.
From 35. So we do that. We have calculators. It's geometry. But the reason why I did it this way is learners tend to try and do a mixed fraction on their calculators. So what happens is they do 2 and then they try to do the fraction and they realize it doesn't work. So then they put in the third and then they go back and put the 6 in front of it. Your calculator, I don't know if you can see that. Even though it looks like what's written on the page, the calculator doesn't actually see it that way. That makes no sense, does it? How can 35 minus 6 be 31? So please be very careful. Do not do mixed fractions on the calculator. So what you could do instead is you could say 35 minus 6 minus 2/3, and that gets me what I need to know. So you can leave it as 85 over 3 if you wanted to. 28 1/3, which also doesn't make any sense. What did I minus? Oh, right. Oh, yes. Okay. So, and we try and do our fraction now, would still be a problem. So we get 27.3 if we did the whole mixed fraction on the calculator, which is definitely, we know, not correct. So 35 minus 23, then minus your 2/3, gives me 34 over 5, 1/3, sorry, gives me sorry, I need to redo the whole thing. Okay, 35 minus 23 equals minus 1/3. There we go. 35 over 3, you're welcome to leave it as the improper, or you can change it to the mixed fraction. But you're most likely going to have to change it back to your improper later on. So when I do that, I'm going to choose right now to keep it as my 35 over 3. So now I can start trying to see if these answers are the same. 15 divided by 5 is 3. Now you can go 20 divided by 6 and 2/3 on the calculator. But once again, if you do it in mixed fraction form on your calculator, it will come out the wrong value. So let's convert that to improper fractions. 6 times 3 is 18. Plus 2 is 20. So that would be 20 over 3. But I do know how to tip and time, so I wouldn't even need the calculator. So because I'm actually dividing, so that would mean tip and times. So my 20s cancel, my answer is just 3. We'll do the same thing here. I know that it's 35 over 1 divided by 35 over 3, so I'm going to tip and times, which cancel, leaving me just with 3. So yes, double check on your calculator. Fractions are in an algebra paper. But yes, we do have a calculator. So I was just practicing some fractions. So my answers are all the same, therefore they are similar. What is my reason this time? What allows me to say they're similar? What did I prove? Sides in proportion. Now that they are in proportion, we know that the angles have to be equal. So what is the value of x? Going back to my picture. They are similar now. Triangle ABC is similar to DEC. That means this angle is obviously equal. This one has to be equal. And those two have to be equal. What was, I would have said there, CDE equals to 70 degrees because they are sides in proportion, they are similar. So how am I going to find x now? Yes, Nicholas. What is your reason? There we go, interior angles of a triangle. So I would first have to say that CDE equals to 70 degrees because triangle ABC similar to triangle DEC. Then I can say x is equal to 180 degrees minus 70 degrees minus 36 degrees, which is equal to what? Interior angles of triangle. So there should be 110, 180, 74, I think. 74 degrees. So that is more actually the kinds of questions that you would have had in a normal grade 9 year. Where we use the similarity to find stuff like angles and stuff. Okay, number 8. Not too difficult. I'll leave it for about 2 minutes and then we will do it together, just so you can think. If you're interested in number 7, you can take a picture of it. Number 8. Giving you another triangle on top of a triangle. There is no missing information, it's missing on purpose. So OG is missing on purpose. The problem should not be the proof, the problem should kind of come in with the x and y. Solve y before you solve x. Okay, 2 minutes are up. So the proof should not have been a problem since I have parallel lines corresponding, common, or corresponding, common, and third angle of a triangle. Okay? Then that means that I can use my ratios. I went and put in my information. I could find y very easily. Y is equal to 4. But how on earth am I going to get to x when x and OG are missing values? Anyone have any kind of ideas? Christina? Pythagoras. There you go. So we have a right angle triangle. There's no other reason that I would have given you the right angle if it was just a random angle. So using my Pythagoras, I have 12 squared plus 9 squared and square rooting. I have TG equal to 15. So that means that that entire side here is equal to 15. X is TO. What would OG be if I have 15 and I have X? 15 minus X. So let's go replace that. I know that the entire TG is 15. OG is 15 minus X. And now I can cross multiply. 9 times the bracket. 3 times 15 is 45. 9 times 15 I think is 100 and something. 135 minus 9x is equal to 45. Minus 9x, 45 minus 135. It's minus 90. Dividing both sides by minus 9, x is equal to 10. So sometimes there are things thrown at you that incorporate other things as well. Okay, so when I see you, the bell's going to ring literally any second. I won't see you tomorrow. When I see you next time, we will go through congruency. Again, it's going to be basic. It's not going to be grade 9 congruency. Not the difficult grade 9 congruency. It's all easy grade 9 congruency. And then we will start with our algebra revision. Probably in the same week, because congruency will go quite quickly. Okay, but that will only be when I see you after the holiday.